this unit term. Yes, okay. Now coming to the next thing over here. A uniform wire of resistance 2.8 ohm has a length of 2 meter. Find the length of the similar wire which is connected in parallel with a 2 ohm long wire. So we'll give this will give a resistance of 2 ohm. Okay, we'll give a resistance of 2 ohm. So 2 ohm means that is a defective resistance. Okay, so the a uniform wire of resistance 2.2 ohm has a length of 2 meter. Okay, so length of this wire is 2 meter. If the resistance R is equal to 2.2 ohm. Okay, so find the length of the similar wire. So which is connected? Similar wire. Similar wire. Okay, similar wire means area of cross section everything is same, right? Okay, so area of cross section everything is same. Okay, see this is similar wire and your resistivity also is same. So connected in parallel with the 2 ohm long wire, 2 meter long wire. Okay, with this wire. Okay, so one more wire is connected in parallel. Will give you a resistance of 2 ohm. Okay, so look at this. This is one wire. So this is the wire of 2 meter length, and its resistance R is equal to 2.2 ohm. Okay, so this is the wire like this. Now to this, so one more wire is connected over here like this. One more wire is connected like this. Okay, so it's the resistance that is R you take. R dash here R dash you take, and effective resistance RP is equal to 2 ohm. Effective resistance RP is equal to 2 ohm. So RP is equal to R dash into 2.2 ohm divided by R dash plus 2.2. So this is 2 is equal to R dash into 2.2 divided by R dash plus 2.2. Okay. So let's here this is 2 R dash plus 4.4 is equal to 2.2 R dash. Right? This is going the sign. 0.2 R dash is equal to 4.4. So R dash is equal to how much? R dash is equal to how much? 22 ohm. 22 ohm. Understood? 22 ohm. Now, length of this wire, you need to find out. So, length, so for the first wire, so R is equal to rho into L by E, okay? Okay, so R means 2.2 is equal to rho into L 2 by A. So 1.1 is equal to rho by A. 1.1 is equal to rho by A. Now, in the second case, R dash, rho into L dash by A only. Similar way to the citizen. But length is different. Length is different. But okay, rho into, okay, this is here. So L dash, R dash is how much? Rho by A, 1.1 into the dash. into L dash. Right? Okay. So how much? So this is L dash. 22 by 11 into. So this is 20. 20 meter. 20 meter. Like this. Now coming to the next thing. Two resistors are in the ratio 1:4. If these are connected in parallel, their total resistance becomes. Should I switch off? Switch off? No need. Now it stop. Okay? Okay, switch off. Okay. This is okay. What are you? Right. Okay. Now, two resistors on the ratio are in the ratio 1:4. If these are connected in parallel, their total resistance becomes 20 ohm. Find the value of each resistance. Okay. The total resistance becomes 20 ohm. Right? 1:4 ratio. The two resistors are in. The two resistors are in the ratio 1:4. 1:4. Okay. So look at this. 1:4 means the first resistance is R. The second resistance is 4R. And if at all these two things are connected in parallel, the effective resistance has become 20 ohm. Okay. So 20 ohm. So this is R into 4R divided by R plus 4R. So this is 20 is equal to R into 4R divided by 5R. Okay, 20 is equal to, okay, 5. R is equal to 25. Okay, so one resistance is 25 ohm, the other one is, okay, like this. Now coming to the next one. A set of N identical resistors, each of resistance R ohm, when connected in series have an effective resistance, okay, X. In the printing that is missing, X ohm. And when the resistors are connected in parallel, their effective resistance is Y. Find the relation between R, X, and Y. Find the relation between R, X, and Y. Okay. See, so the given situation in this particular case is a set of N identical resistors. Each of resistance R ohm. Okay, N identical resistors. When connected in series, have an effective resistance X. Am I correct? Okay. Okay. So when they are connected in parallel, effective resistance is 1. Okay, so effective resistance is Y. So that is RP. RP is equal to Y. 1 by RP, 1 by R, 1 by R, and so on. This 1 by R, by this N number of resistors, that is N times. So 1 by RP, N by R. That implies RP, R by N. So Y is equal to R by N. So N is equal to R by Y. N is equal to R by Y. So from these two equations, X by R, R by Y. Okay, so that is X into Y is equal to R square. X into Y is equal to R square. That is the relation. That is the relation. Okay, next step. A parallel combination of 3 resistors takes a current of 7.5 ampere from a 30-volt supply. If the resistors are 10 ohm and 12 ohm, find the third one. Find the third one. Okay. So look at this. A parallel combination of three resistors takes a current 7.5. Complete parallel combination. Okay, so there is a 7.5 ohm, so amp. Okay, from a 30 volt supply. 30 volts. If the two resistors are 10 volt and 12 volt, R1 is equal to 10 volt and R2 is equal to 12 volt. Find the third one, R3 is equal to how much? R3 is equal to how much? Okay, right. Now, from these two things, what should be the effective resistance? That will be the effective resistance in the parallel combination. That will be the effective resistance of the parallel combination. So V by I. So 30 by 7.5. 300 by 75. 300 by 75. So how many times? Okay. Okay, there's a here. So effective resistance is 4. Effective resistance is 4. Okay. Now 1 by 4. Okay. So 1 by 4 is equal to 1 by 4. 1 by 12. 1 by 4. Okay. So 1 by 4. So this is so 12 plus 10. 12 plus 10 plus 1 by R3. Okay. 1 by R3 is equal to so 11 times 5 times. Okay. So 1 by 4 minus 11 by. Understood? So 60 is 15 minus 11. So R3 is equal to 15 ohm, like this. Okay. Next, when a current of 0.5 ampere is drawn from a battery, the potential difference between the terminals is 19 volt. And when a current of 2 ampere is drawn, the potential difference across the terminals drops to 16 volt. So this will determine the electromotive force. Determine the electromotive force. Determine the electromotive force. When a current of 0.5 ampere is drawn, okay, so there is I1, 0.5 ampere is drawn. The potential difference between the terminals is 19 volt. Okay, 19 volts. When a current of 2 ampere is drawn, second is, okay, the potential difference between the terminals is 16 volt. Determine the EMF, epsilon is equal to how much? Epsilon is equal to how much? But okay, so that's what is the formula? What is the formula? Terminal voltage V is equal to electromotive force minus current into internal resistance. Current into internal resistance. Understood? In these two things, same cell, same battery. So same electromotive force and same internal resistance. Only these two things. Okay, we'll change. Right? Okay. Now, so in this particular case, V1 epsilon minus I1 R. V2 is equal to epsilon minus I2 R. I2 R. Understood? Okay. So now, So this here V1, how much? Electromotive force minus 0.5 into R, and V2, this is 16 epsilon minus 2 into R. 2 into R. Understood? Okay. Now coming to, okay, so this is if you solve these two equations. You solve these two equations, right? Subtract. Okay. So this plus this is 1 by 2. Okay, minus 1 by 2 plus 2. Minus 1 by 2 plus 2. How much? Minus plus 3 by 2. That means 1.5. Understood? Therefore, R is equal to internal resistance is 2. Now, the 2 ohm you substitute in any one of the equations. First equation you take 19. Okay, so 3 R. Sorry. Okay, so R is okay. So epsilon is equal to 22 ohms. Here 20 is given on. What is? Okay, I was thinking this thing. Okay. I took this equation, but it's quadratic. Okay, epsilon minus 0.5 into 2. Okay, 0.5 into 2, 1. So epsilon is 2. Okay, right. So 20 volt. Okay, calculate the internal resistance in the above problem. 2 ohm. Already we have calculated. Right, next. So two cells A and B are connected in series, each having an EMF of 1.5 volt. The internal resistances of A and B are 0.5 ohm and 0.25 ohm respectively. Determine the circuit current. Determine the circuit current. Two cells A and B are connected in series, each having an EMF. Okay, that's 1.5 volt. Okay, so electromotive force of A, electromotive force of B is also 1.5 volt. The internal resistances of A and B are, internal resistance of A is 0.5 ohm, internal resistance of B is 0.25 ohm. Okay, determine the circuit current. Circuit current I is equal to how much? Circuit current I is equal to how much? Okay, circuit current I is equal to how much? Okay, so look at this here. How are they connected? They are connected in series. In the series combination, in the sense the same current. Okay, so here series combination means the same current passes. Series combination means the same current passes. Same current passes. Same current. Okay. So if this here, so terminal voltage. Okay. Actually, this here. So terminal voltages are given here. Circuit current. There is no external resistance. Okay. So this here you see here epsilon A. Okay, I into RA. Understood? Otherwise, the terminal voltage you take. So it's epsilon A minus I into R. Understand? Yes, sir. Okay, and so in the second case, terminal voltage is equal to epsilon A B minus I into R. Like this, we can take up. Otherwise, one more approach also I will give you. There is no external resistance, and moreover, these two things are connected in series. In the series combination, effective internal resistance R dash, RA plus RB. In the series combination, potential splits. So effective potential, V I say. So there is epsilon A plus epsilon. V1 plus V2. V is equal to V1 plus V2. Okay. So that implies R dash is equal to how much? 0.5 plus 0.25, 0.75. So this is how much? 1.5, 1.5, 3 volt. So what is the current now? What is the current? V by R dash. So this becomes a 3 by 0.75, 300.75. So that is a 4 ampere. That has to be 4 ampere. So 1 ampere is given here. 1 ampere is given. So that is wrong answer. Okay, 4 ampere it has to. That has to be 4 ampere. Bonus. Okay. Right. Okay. So in the above problem, calculate the potential difference across the terminals of the cell A. Of the cell A. Okay. Across the cell A. So potential difference you need to calculate. Okay. So potential difference. This is epsilon A. This is RA. Right? Okay. So potential across A is equal to epsilon A minus current passing through this into RE. So this is 1.5 minus. Okay. So current. So we got 4 into RA is how much? 0.5 means 1 by 2. Okay. So 1.5 minus 2. So there is a minus 0.2. 0.5 volt. There's one option to it. So there is a typing mistake. Okay. From the next examination, if you have like that, I will check. I will work out. Okay. I will work out. Then I will type. Okay. Right. Next, one more. 45 also. It may happen. Okay. So in the problem number 43, what is the potential difference across the terminals of the cell B? You calculate and then like this. VB is equal to. So epsilon B minus I into R. Minus 1.5 or 1.5. 1.25 is given. Minus. Okay. Minus or plus is here. That is towards the negative terminal, towards the positive terminal. Okay. So the minus sign you can ignore. But okay. That's here 1.5. Not 1.25. But the answer is 1.25 given here. Understood? Okay. Okay. So like this. Yes. So 3 cells of EMF. What is the time now? 5:40. 30 minutes. Okay, we can finish. So 3 cells of EMF 2 volts, 1.9 volts, and 1.8 volts. are connected in series. The internal resistances of the cells are 0.05 ohm, 0.06 ohm, and 0.07 ohm respectively. Okay, the battery is connected to an external resistance of 5 ohm via very low resistance ammeter. What will be the reading of ammeter? Okay, what will be the reading of the ammeter means indirectly what is he asking? Current because ammeter is the device which is used to measure the current. To measure the current. To measure the current. Okay, right now. So look at this here. You see, there are 3 cells. Okay, so electromotive force 1 is equal to 2 volts. The second cell's electromotive force is 1.9 volts, and the third cell's electromotive force is 1.8 volts. And their internal resistances, if at all you take, so the internal resistance R1 is equal to 0.05 ohm. The internal resistance R2 is equal to 0.06 ohm. The internal resistance R3 is equal to 0.07 ohm. The battery is connected to an external resistance of 5 ohm. Capital R is equal to 5 ohm. Okay, all these 3 cells are connected in series combination. Series combination means through each cell same current passes. Through each cell, okay, same current passes. Correct? Same current passes. Right? Okay, so there are 3 cells. Okay, so what is the formula? What is the formula? So you put up, okay, so this again, so here, epsilon. Current I is equal to. Okay, if equal resistance, if equal electromotive forces are there, okay, so N into epsilon divided by, okay, series resistance N into small r plus capital R in the series combination. But this formula in this situation we cannot use because okay, so the internal resistances are not same, electromotive forces are not same. Electromotive forces and internal resistances, both the things are different. When both the things are different, then what do you say? So this is separately we have taken. Okay, so by use of this formula you can take. Okay, so epsilon 1 plus epsilon 2 plus epsilon 3. So this is 2 plus 1.9 plus 1.8 divided by internal resistance. Okay, R1 plus R2 plus R3 because in this combination. So that is 0.05 plus 0.06 plus 0.07 plus external resistance. Okay, so current I is equal to, okay, so 1.9 plus 1.8. How much? 3.7. 3.7, 5.7. Understood? Okay, so this is how much? 11, 18, 0.18. 0.18. Understood? Okay, that's fine. So 5.18. 5.18. So this is 57 into 10 power minus 1. 518 into 10 power minus 2. This 10 power minus 1. So this is 570 divided by 580. 570 divided by 580 means 1 point something. That's so you will get. Is there any option with 1 point? Option B. Option B. You need not even go for a division. Option B, 1.1 ampere. Okay, next 47. 2 identical cells, whether joined together in series or in parallel, give the same current when connected to an external resistance of 1 ohm. Find the internal resistance of each cell. Find the internal resistance of each cell. 2 identical cells. 2 identical cells means electromotive forces are same and given internal resistance are also same. Yes or no? Given internal resistances are also same. Okay, so that's here. That's first they are connected in series. When they are connected in series, what is the current equation? When they are connected in parallel, what is the current equation? This is a series, parallel. Okay, so and epsilon. Did you remember? Okay, very, very important observation. Okay, so that's the same current. He says, right? So n epsilon by so these two things will get cancelled out. So r plus n into r plus r. Got it? So what is the data now? Two identical cells, n is equal to 2. N is equal to 2. Okay, joined together in series or in parallel. Give the same current when connected to the external resistance of 1 ohm. Capital R is equal to 1. Okay, small r. Okay. Understood? Okay, so R plus 2R plus 1. Okay, R is equal to 1. R is equal to 1. So 1. Option C is correct. Option C is correct. Okay, so next question number 48. The potential difference of a cell, okay, on open circuit is 6 volts, which falls to 4 volt when a current of 4 ampere is drawn from the cell. Find the internal resistance of the cell. Find the internal resistance of the cell. So look at this, the potential difference of the cell, okay, of an open circuit. Open circuit means what? So open circuit, if you take, open circuit, if you take, okay, the potential in the open circuit is nothing but direct force. So 6 volt is nothing but direct force, which falls to 4 volt, so a current of 4 ampere. 4 ampere. So a terminal voltage becomes 4 volt. Okay, from the cell, find the internal resistance of the cell. Small r is equal to how much? We know that. Okay, so we 6 months. Okay, so current. Okay, so 4R. Okay, 0.5. 0.5 is not there here. 1 ohm is given. 1 ohm is given. Okay, 1 ohm is not possible. 1 ohm is not possible. 0.5. Okay. Okay. Next question. A secondary cell after a long use has an EMF of 1.8 volt and internal resistance of 350 ohm. So what maximum current can be drawn from the cell? What maximum current can be drawn from the cell? Okay. So what is the maximum current? When will the current be maximum through a cell? When the internal resistance is zero. Okay, so a secondary cell after a long use has an EMF 1.8 volt. Okay, okay, so this is 1.8 volt. Okay, EMF. So epsilon has been given, and internal resistance is small r. What maximum? Okay, current. So I is equal to. Okay, epsilon by r. So 1.8. Okay, so this is 18 into 10 power minus 1 by 350. Right, this is also going down. So 18 by 35, 10 power minus 2. Right. Okay, So I will do one thing. This is 180 by 35 into 10 power minus 3, 180. So 35. So how many times? 5 times. So 5. 5.1 like that is coming into 10 power minus 3. Okay. So 5. 5.1 means 5 to take approximate. So that is 0.005 ampere. 0.005 ampere. Option A is correct. Next, so question number 15. A battery of EMF 4 volt and internal resistance 2 volt is joined to a resistor of 8 ohm. What additional resistance in series with 8 ohm resistor would produce a terminal potential difference of 3.6 volt? Okay, so a battery of EMF 4 volts. Okay, internal resistance R is equal to 2 ohm. Is joined to a resistor of 8 ohm. What additional resistance in series with 8 ohm? Okay, would produce a terminal potential difference of 3.6. So to have this 3.6, this alone should not be taken. Some RS should be taken. RS is 8 plus R. Understood? R means not this 8 ohm. Did you understand that? Some additional, okay. So you need to connect with the, so in series. Question number 50. With what additional resistance in series with the 8 volt? Series R1 plus R. Yes or no? Okay. Now V epsilon minus, okay, I into R. Right? Okay. So R value is very defined. RS. RS 8 plus R. Understood? Okay. So this is coming this way. I into 8 plus capital R plus small. Understood? And first of all, what is the current? From these two things, current you find out. So this is 4 by 2. So I is equal to 2 amperes of current is possible. 2 amperes of current is possible. Understood? Okay. So 2 into 8 plus R plus 2 is equal to 4. So this 2 times 8 plus 2, 10. 10 plus small r is equal to 2. R is equal to minus minus 8. Okay, but look at this. Okay, so I into, okay, R plus 10. Okay, is equal to epsilon. Is equal to epsilon. So I into total resistance is equal to this. Are you getting my point? Okay, so then the resistance which is to be connected will be how much? Resistance which is to be connected. How much? 12 minus 8. Got it? That's. But 8, this answer is not there here. Okay, 10 ohm is given, which is nearer. Okay? Pardon? V value is given. Okay. So that's the producer. Wait. The V value is given now. That I did not see. V value has been given. Okay, I was thinking that this V value is not given, right? Okay, so V value is given here. Okay, so by means of this, how do you say now? 3.6 epsilon value I 2. So this is 2I 4 minus 3.6. So I is equal to 0.2 ampere, right? Okay. Now what is the so there's a terminal voltage now. Well, okay, let's say here. So the series conversion when it is connected. When it is connected, V RS. V into RS. Okay, so 3.6 I 0.2. Okay, R plus H. Understand? 18. Yes or no? Understand? Right. Okay, this terminal voltage I did not see here. I was thinking that the terminal voltage is not given, that's why. So here I RS they have taken. Okay, right. Next question number 51. 3 cells of I know. Dhanlakshmi, your name? Dhanlakshmi, take over. What is the time now? 6. Okay. Okay. So this we will do one thing. Okay. So these remaining problems and the second paper next week will be how to discuss. I am ready because tonight I will be staying here. Early in the morning, by 4 o'clock, I will wake up. By 5 o'clock, I will start. Okay. If at all you are ready to have the class, not one or two. This here the whole class looking in the whole thing, no? Okay. So this we will stop. Okay. Okay. So this if at all this will have. Okay. So actually and other things are taking some gap also we will. Okay. After you like let me just this paper we will finish. Okay, this paper we will finish. Next paper next week is the review. Okay. All right. Okay. Question number 51. 3 cells of EMF 1.1 volts, 1.3 volts, and 1.5 volts are connected in series to supply current. Okay, to an external resistance of 1.6 ohm. Okay, so this here there are 3 electromotive forces. There are 3 electromotive forces. Okay, so look at this here. The first electromotive force is 1.1 volts. The second electromotive force is 1.3 volts. and the third electromotive force is 1.5 volts, are connected in series combination in the sense effective electromotive force 1.1 plus 1.3 plus 1.5. This is 3.9 volts. Okay, right? Okay, so what else is given here? To supply current to an external resistance R 1.6 ohm. The internal resistances of three cells are 0.25 respectively. Determine the current. Okay, so R1 is equal to 0.25 ohm, R2 is equal to 0.35 ohm, R3 is equal to 0.4 ohm. Effective resistance in the series combination. Okay, how much? This is 4. Okay, 6. 0.64. 0.64. Got it? Okay, so what is the current? Current. Effective electromotive force divided by effective internal resistance plus external resistance. Okay, now 0.4. Okay. So, okay. Okay, now so how much? 1.6, 3.9. 3.9. 1. Okay, 1.6. 3.9. So 39 by 26. 1 point something. 1.5. 5. That's okay, like this. Now coming to question number 52. 6 cells each of EMF E and internal resistance of 2 ohm are connected in parallel across an external resistance of 5 ohm. What is the current delivered by the battery? What is the current delivered by the battery? Okay. Okay, look at this. 6 cells each of EMF E and internal resistance 2 ohm. Okay, so each cell's electromotive force is E. Each cell's internal resistance R is equal to 2 ohm. Are connected in parallel. Got it? So this across an external resistance 5 ohm. Capital R is equal to 5 ohm. What is the current delivered by the battery? I is equal to how much? I is equal to how much? Understood? Look at this in the parallel combination. N epsilon divided by in parallel combination, that is the formula. That is the formula. Okay, but in this case, even the E value should be given. E value should be given. Okay, so that is missing over there. That is missing over there. Got it? So grace. Okay, grace. Okay. Pardon? What here? Okay, so the question number 53. The potential difference across a cell is 1.8 volts when a current of 0.5 ampere is drawn from it. The potential difference falls to 1.6 volt when a current of 1 ampere is drawn. Find the EMF. Find the EMF. So look at this problem. Look at this problem. The potential difference across a cell. Okay. So the potential difference across a cell. So this is V1 is equal to 1.8 volt when a current I1 is equal to 0.5 ampere is drawn from it. The potential difference falls to 1.6 volts when a current of 1 ampere is drawn. Find the EMF. Same cell. Same cell means in both the cases epsilon and the internal resistance also will be the same. For this, what is the general formula? Okay, so epsilon minus IR. Okay, so V1 epsilon minus I1R. So 1.8 is equal to epsilon minus 0.5 into R. Equation 1. Next, like that V2, 1.6 is equal to epsilon minus 1 into R. Equation 2. Solve these two equations. Okay, subtraction 0.2. Okay, minus 0.5 plus 1. How much? Understand? Therefore, R is equal to 0.8. 0.4 ohm. Substitute this R in one of the equations. 1.8. Okay, so 0.5, 0.4, 1.8, 0. Okay, so epsilon is equal to 2. Right? Next, in the above problem, calculate the internal resistance 0.4 ohm. We calculate. Next, question number 55. A storage battery has an EMF of 25 volt and internal resistance 0.2 ohm. Calculate the terminal voltage of the battery when it is delivering 8 ampere of current. Okay, so electromotive force 25 volts and internal resistance are 0.2 ohm. Calculate the terminal voltage of the battery when the current delivered is 8 ampere. When the current delivered is 8 ampere. Okay. Right? Okay. So V. So V. So V. How much is? So V is equal to 23.4 volts. Next question number 56. 1 million electrons are passing through a cross section of a conductor in 1 millisecond. What is the current through the conductor? Okay, so look at this. 1 million electrons are passing through. 10 power 6 are passing through a cross section of a conductor in 1 millisecond. Okay, what is the current passing through it? Okay. Understood? So I is equal to, you need to calculate the current through the conductor. I 10 power 6, 10 power minus 19. Okay, 1 millisecond, 10 power minus 3 seconds. This is I is equal to 1.6 ampere. Okay. Next, question number 57. How many electrons pass through a cross section of a wire to make a current of 1 ampere? 6.25 into 10 power 8. Understood? Very, very simple. Okay. I hope you can do this. Okay. Question number 58. How many electrons pass through a wire in 2 minutes if the current passing through the wire is 300 milliampere? Okay. Okay. What is the zero? Zero came here. Okay. Right. So how many electrons pass through the wire in 2 minutes? 2 minutes. 2 into 60 seconds. Okay. So when the current, okay, so the passing through the wire is 300 milliampere. 10 power minus 3 ampere. 3 into 10 power minus 1 ampere. Okay, we know that. Okay, so 3 into 10 power minus 1 is equal to Q by 2 into 60. So Q is equal to 3 into 2 into 60 into 10 power minus 1. So this will get cancelled out. So M is equal to, okay, number of electrons we need to find out. Okay, so 3 into 2 into 6 divided by 1.6 into 10 power minus 19. Okay, so this is 0.8 times. So this is 18 by 8, 10 power 20. Understood? Okay, so this is 9 by 4, 10 power 20. So this is 2.25, 10 power 20. So option B is correct. Okay, so 59. A wire is carrying a current. Is it charged? Is it charged? No. Why? Reason. When did you say? Now I did not say anything. Why I said? Charges are? That's why. Okay, so actually, let's say if it is insulated, just like a glass or anything, what happens now? Loss of electrons will be there, gain of electrons will be there. Okay, deficit of electrons, surplus of electrons, by means of which charge is exhibited. But in the case of conductors, when the electric current is passing, what happens? What about the charges? Okay, so that you are giving the charges are taken inside. Okay, how many negatives electrons are passing? Okay, so that means okay, there's a positive charges there, there's a positive ions. Okay, both of things will get noticed. So overall, inside negative charges will be there, positive charges will be there, but overall outside. So when some amount of current is passing, the conductor will not get charged. No charge gets available. Understood? The last one of the paper, the last question of the date. Okay. But now this is happiness is coming on there. Sapna, at last we came to last question. Okay. The resistivity of a wire is 1.963 into 10 power minus 8 ohm meter. What is the conductivity? So resistivity, okay, 1.963 into 10 power minus 8. So conductivity, or reciprocal of this, that's you need to do. 1 by 1.963, that's I will take 2 approximate. There will be no danger. Any danger? No danger. Okay. 10 power each. Approximately 0.5 into 10 power each. Now search for the nearest answer. So 5 into 10 power 7. 5 into 10 power 7. Got it? Okay, successfully the paper is over. Where are the OMR sheets with people there? You have given out? Huh? Okay. So this is okay. You know. Okay. So tomorrow from that wherever you collect your OMR sheets back and you evaluate. Okay. So for questions, okay, wherever